Hi, welcome. I'm Shi Luo. I'm going to make a presentation about my graduate project, Predicting Stock Market Movement Using Everyday News Headlines, for the course CACIE 29. And the course was in the spring of 2018, and this is our great teaching staff. This project is going to predict using the top 25 news headlines to predict the movement of Dow Jones Industrial Average Index. As for the methods, there are two data sets. One is the top 25 news headlines for each day from 2008 to 2016 as a predictor. And the second is the DJIA rate of return in the same day as the outcome. And the news titles map to a pre-trained vector, which is GLOVE. And the recurrent neural network-based models and convolutional neural networks models are used. These are the required libraries, except for those like pandas and NumPy. We just install use conda. But for the GLOVE, we don't need to install. We just go to this website and follow the instruction to download the file that you need. I'll go through this workflow with my notebook. There are 5 steps altogether, and the first one is to import data. As I mentioned just now, I have 2 data sets, news headlines and DJIA prices. The data are from Kaggle, and at first we need to import libraries and import data. This is one data frame, news, and it has the first column for date and the others for the top 25 headlines. And this is DJIA, and the first column is also date, and the others are other kinds of prices. I would drop rows with empty and name values, and we check the shape. And now we come to the data processing. And as you can see, this is the most time-consuming part, and it took most of my time to do this. And in this part, we have 4 steps. First is data processing. I'll calculate the rate of return based on close prices, and this is the formulation I used. So after calculating this, I drop all the other columns and reset the index. We get a new data frame. Then I will merge this data frame with the news. We get this and get rid of the rows that they don't have in common. Now it's time to create input and output data sets. And I combined all the 25 news into one for each row. And we get 2 lists. One is headline, and the other is rate of return. Now I build a function to clean the new headlines. Yes, I remove the punctuations, convert words to lowercase, and remove stop words and replace certain expressions, and then lemmatization. Now we get a clean headline, like this. Next step is tokenization. And then we pad these sequences to the same length and get this array. You can see that they are all in numbers instead of text. And the last step is to apply GLOVE's embeddings. And GLOVE is Global Vector for Word Representation, released by Stanford NLP Group researchers. It is famous with Google's Word2Vec package, and I choose this file as embeddings. Before training, I will create a matrix. Okay, now it's time to build our models. I have two models. As you can see, after setting the parameters and the model 1, in this model, I applied glove embeddings and simple RNS layers. And word embedding is the way how we represent words to input them in a neural network. There are one layer of embedding and the 3 layers of RNN and ended with a dense layer. For Model 2, I implemented glove embedding, convolutional 1D, and long short-term memory LSTM network layers. Yes. After splitting data, we feed a model, and I set up epochs into 30 for both models. And now it's time to check our results because I used the continuous rate of return data, so I don't get a accuracy score. So I have to do it manually by this code. I calculated the accuracy for both models. They are all around 50. And the last part is visualization. Yes, we can see from these two graphs that the second one is better. So it's the discussion. As a result, models don't behave so well as I thought. They're only 50. But I think there are several ways to get better, to narrow the range of news and consider the time factors. At last, I think predicting the capital markets would be a permanent task. And these are the links that you can download the data from this Kaggle and the notebook from my GitHub. Yes, these are the references. And thanks for watching. Hope you like it.